The risks of using legacy data in mineral resource estimation. Welcome to Mineral Projects Intel, where we dig deeper into the world of mineral projects, where we unpack the complex world of mineral projects investment, and where we make sense of the science, strategy, and sometimes the jargon behind it all. If you've ever wondered how the wealth of historical drilling data accumulated over the long history of mining can fully support a mineral resource estimate, you're in the right place. In this video, we will discuss the specific risks associated with legacy data, and by the end, you'll understand these risks and their effect on mineral resource estimation. One of the biggest misconceptions in mining is that a large historical dataset automatically means a reliable resource. In reality, legacy data carries several specific risks that can materially bias a mineral resource estimate if they are not properly identified and managed. The first major risk is sampling bias. Much historical data, particularly from underground gold mines, was collected for grade control or production reconciliation rather than resource estimation. Chip samples, grab samples, and channel samples were often selectively taken from visible mineralization, which can overstate grade. Sampling widths may not represent true mining widths, and dilution was frequently ignored. When this type of data is used directly in modern models, it can systematically inflate grades and create unrealistic expectations. A second critical risk is the absence or inadequacy of QA/QC documentation. Many historical datasets predate routine use of certified reference materials, blanks, and duplicates. Original laboratory certificates are often missing, and analytical methods may have changed over time. Without QA/QC, it is impossible to quantify analytical accuracy or precision. Even if results appear consistent, there is no defensible way to prove that assays are unbiased or comparable to modern data. Another common issue is survey and spatial uncertainty. Older drill holes and underground sample locations were often surveyed using manual or local grid systems with limited accuracy. Coordinate transformations may be poorly documented, and elevations can be uncertain. In narrow reef gold systems, small spatial errors can result in large grade and thickness misplacements. This directly affects geological continuity, variography, and ultimately resource classification. A further risk lies in inconsistent data collection standards. Over decades of mining, different geologists, samplers, and contractors applied different protocols, logging styles, and sampling methods. Changes in drill type, core diameter, recovery handling, and sampling intervals introduce non-geological variability into the dataset. When combined without careful domaining or weighting, these inconsistencies can distort grade distributions and variograms. There is also the risk of survivorship and economic bias. Historical data is often concentrated in areas that were already profitable to mine. Marginal or low-grade zones were undersampled or ignored. This creates datasets that are not spatially or statistically representative of the full ore body. When extrapolated into unmined areas, such data can over-predict grade and continuity. Finally, legacy data presents challenges for confidence and classification. Under modern reporting codes like SAMREC and JORC, mineral resource classification depends not just on data quantity, but on data quality, verification, and geological confidence. If legacy data cannot be validated or verified, it generally limits the resource to lower confidence categories, regardless of drilling density. Overclassification based on historical data is one of the most common and serious reporting risks. In the Part 3 video, we'll unpack what geologists must do to responsibly use legacy data and report resources derived from legacy information. Understanding how to utilize the wealth of data accumulated in the old mines is essential, especially in mature mining jurisdictions like South Africa, where the past strongly shapes today's resource models. If you found this useful, like, subscribe, and share for more mining insights. Because in the resource world, knowledge isn't just power, it's value. Thanks for watching.